This video is brought to you by the Bates College Digital and Computational Studies program under a Creative Commons Attribution Share Alike version 4.0 license. Good evening. It is 8:45. I am in CoCalc, and I'm going to put together a brief introduction to the authoring of functions in Python. There will also be a tutorial that I distribute. And so this, I hope, will serve as an introduction for you. I'd like to remind you that while I'm traveling, we will be able to connect up on Skype. But I hope that you watch this and do the tutorial in preparation for coming in and continuing to engage in the classroom. All right, so functions. They have things that come in and things that go out. Another way to put that is a function is a sequence of statements or computational expressions that execute, and we give them a name so we can reuse them over and over and over. And what makes them truly powerful is that we can then parameterize them. So let's take a look at that idea. First of all, we are introducing a new syntax. By that I mean that, as you know, in Python, there is a syntax for if statements, and that is that there's an if, a conditional, and a colon, and then we indent, and then there's the stuff that we do. So that's the syntax for an if. Function definitions. Before I go to definitions, you have seen how we use functions. So we've done things like, I think that we. We've done this. We've written code like this. All right, so we can say like the value of this function comes back, and we can store it in a variable. I think we also. I'm tired at the end of the day, so I'm struggling to come up with examples from our code off the top of my head. I apologize. I'm doing this on the fly. It's not scripted. So we have used functions, though, many times. Now, to author our own functions, the syntax is that we say def. We have the name of a function. And then we have some parentheses, and I'm going to put a ... there. There's things that might go inside of those parentheses or might not. We have a colon, and then we indent. And then we have code. We'll say what the function does. And that can be multiple lines, multiple things that the function does. And typically, I'm going to introduce you initially to functions that return a value. All right, so that means return, and then we have the result of the function's computation. All right, we should have 3 dots there. All right, so we have a we have the letters def. We have the name of our function. We might have some things in here. Those are parameters. Then we have whatever our function does, and the last thing is we have a return, and that returns the result of the function's computation. Let's keep that here for a minute. And so I'll comment it out and introduce a new computational cell. I did that by pressing, I think, Command and Return, which, well, for some reason it runs the cell and introduces a new one. All right, so as an example, I can write a really useless function. I could call it compute8. And it takes no parameters. Right. As a matter of style, I'm going to keep a space here. It's not strictly required, but it'll keep the name completely separate, and it'll show us then what do I pass as parameters. There are none here, and the entire computation I'm going to do is return 3 plus 5. And if I then tell CoCalc to execute that, nothing happens because I have not used the function. So I could say print, or better yet, we can just say compute 8. All right. And we'll run it, and it says the result of the function compute 8 is 8. I could take the variable x and assign it the value of the result or return value of the function compute 8, and nothing would come back, but I could ask what x is, and it would tell me that x is 8. The joy of doing screencasts is if you have questions or are uncertain about something, or if I've done something that confused you, you can't ask me a question right now. I want to be clear, that's not a very useful function. It does the same thing every time, and it's really uninteresting. So to make functions interesting, they need parameters, and typically they need to do more computations. So we can say def, we could say add 8, okay, and we could then say that we want to return your number plus 8. That is, say I'd like to take a number that you give me and add 8 to it. And that is what the function add 8 does. Now, I've just introduced this variable, but I think the idea that we want here is that somehow you can change that so that you could say I want 10 plus 8 or 20 plus 8. I mean, everybody wants to add 8 to things. In case you weren't sure about that, it's like the most important thing at Bates College right now. So that's actually what you put in the parentheses. That is the parameter to the function, and it is a variable. It is essentially a special kind of variable that exists then only in the body of the function. And the question is, though, how does it get its value? What is the value of your number if it's a variable? So here you go. So up above in cell 3, we called our function by invoking it. We said the name of the function, and then we put some parentheses. And that's how we call a function. We've been doing that quite a bit already. So if I run that code, Python just loses its mind. It says add 8 takes exactly 1 argument, 0 given. Now Python uses the word argument. So arguments and parameters are the same thing for today. And many computer scientists will use those words interchangeably. They will say the arguments of the function or the parameters of the function. There's actually some very precise language, and Python has it wrong. I can't fix that. It's too bad. But I digress. What it has told me is that add 8 takes exactly 1 argument. And the arguments go inside of these parentheses. So let's try this again. Add 8. I want to add 8 to the number 0. What do I get? I get 8. That's pretty cool. That is the additive identity, for those of you who are following along. All right, so add 8 to 10. I think we're going to get 19. We're going to get 19. Oh, 18. Okay, all right. That was no good. But actually, that's correct. So that is good. And I could say I want to add 8 to 20. That'll give us 27. 28. Okay. That's correct. I just can't add anymore. Now, you also saw earlier how I was able to store the result of the computation. So I could say y is equal to add 8 of given the parameter 30. And so the function takes in the number 30. It assigns the number 30 to this parameter, and then inside of the function, I can use the parameter and do things with it and return a value. So I can then, all right, that's cool. And what is the value of y? 38. It's amazing. So far, you have seen a function that has 1 line of code in it, and it has 1 parameter. Let's take this up a notch, shall we? All right, this is going to be mad crazy. Let's add 8 and divide by 2. So I could say add 8 and divide. That's a long function name. and it will take your number, u number, as a parameter. And we could say that the addition result is equal to your number plus 8. Now you'd be like, Matt, where did you come up with addition result? Like, wait, right, you're probably losing your mind at about now. Like, it's already moving fast enough. You probably went back and listened to some things more than once. You're still confused. And now I'm like making stuff up. You're like, how did you decide to do that? All right. The names of parameters can be anything you want. It's best if they make sense to you and maybe other human beings. Likewise, the names of functions can be anything you want. It's best if they make sense in terms of what the function does. And if you hopefully recall, this is an assignment statement. So that's where we say a variable is equal to a value. All right. So we are assigning some value to a variable. The value is the parameter your number added to 8, and we are storing it in a variable that I have just declared. I've created it, and I'm going to call it the addition result, because I'm then going to create a division result, which is equal to I'm all right. The division result is equal to the addition result divided by 2. This is amazing. And maybe I should change this name to divide by 2, because that's what we're doing. So now I will return the division result. Function definitions, if they are syntactically correct, will produce no output in CoCalc. If I make a mistake, if I forget a colon, I get a syntax error. It says something like invalid syntax. That is almost amazing. Let me get rid of that one. So if I come back here and I rerun the cell, everything is happy. And now I can say add 8 and divide by 2. And I'd like to do that with the number 10. 10 plus 8 should be 18. Divided by 2 is 9. I can say add 8 and divide by 2 of the number 11. Now what's going to come back here? All right, 11 plus 8 is 19, divided by 2 is 9. It turns out that Python is doing integer division, so it is only giving me whole numbers. That is a really interesting thing for us to think about and muse on. There's a way that we can change it so we would get a decimal number back. I will tell you that for right now, it's okay and doesn't matter. Or if you prefer, we can talk more about that, and it's actually a very small change to get decimals back. Now, I'm going to take us one step further, having more than one parameter. All right, so I'm going to take the same function. I'm going to call it add 8 and divide. But this time I want to be able to divide a number of your choosing by a divisor of your choosing. So now we're going to have much the same. The addition result is equal to your number plus 8. But now the division result is equal to the addition result divided by your divisor. I'm going to return the division result. I've written syntactically correct Python, but now if I say add 8 and divide, and I want to do that with the number 10, oops, this is a different function. It takes 2 arguments, not 1. So I can say add 8 to 10. That gives me 18, which I could then divide by 3 and get 6. I could add 8 and divide to the number 10 and divide it by 6, and I should get 3. Because 10 plus 8 is 18, divided by 6 is 3. I'm going to guess because I have never, as a computer scientist, ever been asked to write a function that adds 8 to something and divides it. However, this is, if I needed to do a mathematical operation to something over and over, I might have one or more parameters that control what I want to do, and the ability to change the parameters of the computation. That is, this computation should always be the same, but sometimes these parameters will change. That is the essence of what we use functions for. Going back to what I mentioned briefly in class, I could say, what is the area of square? So if I want to know the area of a square, if I asked you to write a function that could calculate the area of a square, you would want to give the function a reasonable name. I might even tell you what the name should be because I need to be able to test it. And you would say, okay, I might even tell you that it needs to have one parameter called side length. And so you would know the name of the function and the name of the parameter and then say, all right, well, I'm going to return the side length times the side length. That becomes a one-line function. So that way I can say if I have an area, I have a square, so then I would write code like this. If I would write the test like this, and I looked up how to do this. I would almost never write code this way except to write this kind of test. Great if area of square 2 equals 4, else bad. All right. So that is an inline if. I'm only writing code that way and giving it to you because it's how I can, in one line, test some simple things. And if I copy that here, so the area of a square with side length 2 should be 4, and if I say 5, then when I run it, it should say bad. So this is a way that I can then ask you to please define a function that is called area of square with side length. I'm expecting you to write code in the definition that will do the right things and return the right value. Sometimes it might be one line. Sometimes you might write multiple lines and have temporary results that you do not return. Well, in this case, you return the division result. But I might then have multiple lines of code like this. So that when you run your code, in this case, that's no good. It only runs one of them. So I would have to have each test in its own cell. And let's pretend that we don't have bad tests because we only want great tests. So I can put this code here and I can tell you go to kernel and restart and run all. Restart and run all cells. And it will run every single cell one at a time. It is working its way down. Is it? Oh, it won't run past an error. So I have to comment out the errors. That's awful. Where else did I have an intentional error? Right there. Restart and run all. There we go. So you can see that it's recomputed every single cell, one after another, and then it gets down here and it tells me great, great, great. And what that tells me is that I have correctly written this function so that if I say the area of square when given a side length of 3 should equal 9, the area of square given the length of 4 should equal 16. And I will often give you this code commented out and ask you to uncomment and run it. And the reason is if you have not defined the function, then this will fail and you can't go on. So I will distribute it like this and ask you, could you please uncomment it and then run it to test your code. I think I've just recorded roughly a 30-minute video. That is a brief introduction to functions. The tutorial I've shared with you has some of the same of this in text. and it asks you to write a few functions. I'm also going to ask you I'm going to have to send you an email with a list of additional functions that you might write and practice writing in class. This is very much drill and practice type work. That is, by writing many functions, what I'm asking you to do is to get used to the syntax of writing a function, of thinking what the parameters are, of thinking what the computation is inside of the function, and thinking about what should you return, so that one or more statements that test your code execute correctly. We will build from here to increasingly complex things, but this is the starting point. So that is the end of my introductory video.